All right, number 19, it says find the values of certain functions of an angle in standard position with measure theta if the point with the given coordinates lies on its terminal side. Terminal side just means where it ends. Initial side always starts sort of at 0 degrees, and this guy's then going through the 0.34. So if we think about this, it's going through over 3, up 4. It's going through this point right here. And we just want to get the sign of this theta right here with its initial side right like that and its terminating side there. We just want to get theta. So how can we do it? Well, quite simple. Draw down your line and say, what do I know is true? Well, you went over 3, so you and I know that this length of this leg is 3. It went up 4, so that leg is 4. So we know 2 out of the 3 legs. It's a right triangle. Let's use Pythagorean theorem to find the hypotenuse in this case. One leg squared plus the other leg squared equals the hypotenuse squared. We should recognize a 3, 4, 5. If you don't, 3 squared plus 4 squared is 25. Square root of 25 is 5. So this guy is now 5. So we have all we need. It just wants you to say sine of theta is what? Well, remember, some old hippie caught another hippie tripping on acid. Sine is opposite divided by hypotenuse. So if we look here, where's opposite? Opposite is 4, hypotenuse is 5. So it's 4 over 5. The cosine is adjacent divided by hypotenuse. The adjacent is right here, 3 divided by hypotenuse, 5. That's all we're looking for. Tangent is opposite over adjacent. Opposite is 4, adjacent is 3. Boom, we got all our answers. The key is you have to draw your triangle, and it's in that first quadrant. We need to draw it, and we need to use the Pythagorean theorem to always find that hypotenuse because we're going to need it on some of the problems. For sine and cosine, you have to have the hypotenuse because it's always opposite over hypotenuse, cosine, adjacent over hypotenuse. So you need that hypotenuse to give the sine and cosine of the functions.